Jim Burnett of NASA's Lewis Research Center in Cleveland, Ohio. In this 7th program of our series, we'll see a film called Your Share in Space, which was first released in 1962.
We've come a long way in the few years since our country began its broad, long-range program of space exploration. Since 1958, when NASA, the National Aeronautics and Space Administration, was established, we've successfully launched scores of spacecraft. Today, it's no longer a question of what can we do in space, but what we want to do. And for many people, the biggest question of all is, why do we want to explore space? What are we getting for the millions we've already spent? And what can we expect from the billions we plan to spend? Much of this questioning of the practical value of space exploration stems from the fact that most of our space activities are primarily concerned with gathering scientific information which often appears meaningless to the layman and seems to have little immediate practical value. The S-15, our gamma-ray astronomy satellite, is a good example of this kind of space experiment. This satellite, while it looks like an old-time street lamp, is actually a miniature observatory equipped with a powerful telescope to detect high-energy gamma rays from cosmic sources. Gamma radiation, which is produced by nuclear activity, has a special interest for scientists because they think it can be the key to valuable new information about the forces and elements that make up the universe. It was the investigation of phenomena such as this in the past that led to the development of electricity, radio, and more recently, nuclear energy. To simplify and reduce the cost of launching experiments such as these, we recently developed the Scout. This 4-stage launch vehicle is powered by solid propellants and gives us a small but highly flexible booster that we can use for a variety of space probes and actual missions. Apart from contributing to our general knowledge about the Earth and the universe around it, our scientific space experiments also give us the special knowledge and experience we must have to use space to improve our life on Earth, which is one of the primary objectives of our space program. In this area of practical applications, we've already made several spectacular achievements. One of these was Echo 1, a communications satellite experiment using a huge inflatable sphere to serve as a reflector for radio signals. The experiment called for the payload to be placed in a 1,000-mile Earth orbit. Here it would be separated from the 3rd stage, and the sphere would be ejected and inflated. Radar tracking stations would observe and plot its course. Skirting the coast of South America, the satellite orbit would extend below the tip of Africa. And coming back over the South Pacific, it would cross between Australia and Asia, proceeding in a northeasterly direction above Wake, Midway, and Hawaii, and down from the North Pacific within range of the NASA Jet Propulsion Laboratories tracking station at Goldstone, California. This station was to be one of the communications points. The Bell Telephone Laboratories at Homedale, New Jersey, was to be the other. When the sphere reached an area of mutual visibility between these 2 points, they would attempt to communicate with each other by bouncing their signals off the satellite. Our first test in the summer of 1960 failed. But several months later, a second attempt was made.
On. Accelerator. On. Start tank. On. Burn your fuel vent. On. Minus 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 1.